In the year 1820, a Danish physicist by the name Hans Christian Oersted found out that whenever current is flowing through a wire, then a magnetic field is produced all around the wire. So earlier, before this, it was thought that magnetic field is produced only by magnets, okay, or any magnetic material. And a current is produced by the flow of electrons through a conductor. But it was earlier thought that there is no connection between the magnetic field and the current, right? But this Danish scientist, he proved otherwise, and his discovery was accidental. One day while he was performing an experiment, he had a wire placed on the table through which current is passed. And beside the wire, he happened to place a compass needle. And when he put on the key, he found that the compass needle deflected. Even without touching anything, the compass needle was just there on the table. So as soon as the current is passed through the wire, the compass needle deflect. So this made him surprised. It surprised him. So being a scientist, he tried to realize, he tried to understand, he tried to find out what is happening out here. So what he did was he changed the direction of the current, and to his surprise again, he saw that the deflection of the compass needle is in the opposite direction. So from this accidental experiment, he performed more experiments, and then later on concluded that whenever current is passing through a wire or any conductor, a magnetic field is produced all around the conductor. Let us discuss this simple experiment of his, the Oersted experiment. This is the simple arrangement of the Oersted experiment. There is a wire AB. The ends of the wire AB is connected to a cell through a key K. And a compass needle is taken. This is a compass needle. All right, this is a simple diagram of a compass needle. It exactly doesn't look like this, but just to give you the idea. Inside of this compass needle, there is a small magnet out here, where the red side is the north pole of the magnet. The black side is the south pole of the magnet. First, the magnet is placed, or the compass needle is placed below the wire, and current is allowed to flow through the wire from B to A in that direction, this current I. So when current is flowing from B to A, it is found that the north pole of the magnet deflect towards the left side. Now the direction of the current is reversed. Now the current is allowed to go from A to B. So when this is done, the deflection of the magnet is also reversed. Now it goes towards the right side. So next, what is done is the magnet is now placed on top of the wire. The compass needle is placed on top of the wire. And when the current is allowed to flow from B to A, now the deflection is towards the left side. Before, when the magnet was below the wire, where was the deflection? The deflection was towards the left side. But now when the magnet is above the wire, the deflection is towards the right side. And when this direction of the current is changed, now current is allowed to go from A to B, as in this figure 5, the deflection is towards the left side. It is found that when the magnet is placed perpendicular to the wire, there is no deflection whatsoever. So from this simple experiment, Rutherford came to the conclusion that a current-carrying conductor always produces a magnetic field. The larger the current, the stronger the magnetic field. Now, how do we know that? When the current is increased, it is found that the deflection of the magnet also increases from its original position. So that is how we come to the conclusion that when the larger the current, the more will be the magnetic field. The magnetic field is produced perpendicular to the wire, and the magnetic field consists of circular lines as shown in this figure here. If the current is going in that direction, then the magnetic field will be in the form of closed loops like that, okay, going in that direction. All right. Now, since the magnetic field is a vector quantity, then what will be the direction of the magnetic field? The direction of this magnetic field lines is given by the right-hand thumb rule. So imagine if you hold this wire and you direct with your right hand, and you direct the thumb in the direction towards the right side, in the direction of the current. Then the four fingers which is wrapping around the wire will give the direction of the magnetic field. Okay, so this is the Oersted'S experiment, which is like a very important experiment, which is like a breakthrough in science.